Good afternoon and welcome to Purdue University in this week's security seminar hosted by CERIAS. I get the opportunity to introduce ever so often our visitors, and it's a special pleasure for me to do today. I've mentioned before when we've had alumni come back and speak, but this is actually an alumnus who was here and was very active with CERIAS, and I got to know when he didn't have as much hair on his face, a few less wrinkles on his face. Still a pretty good looking guy, but it's exciting to have one of our alums come back who has gone out and done remarkable things in the industry and continues to make us extremely proud. So it is my pleasure today to introduce our speaker, Jason Ortiz. Jason is a senior integration engineer with the security company Pondurance, located in Indianapolis. Jason, welcome back to campus.
Thank you. I'm really glad to be back. So I'm going to move around a little bit. Hope everybody's okay with that. I don't like standing behind the podium. It seems a little too formal for me. So everybody's in the right room, right? We're going to talk about IoT security, living on the edge. So this is intended to be a very lighthearted, kind of funny at times talk, maybe a little interactive. So hopefully it's not too boring. I know you've all had a long day of class and homework. You probably still have more homework. So, I'm going to try to make this a little more fun than, linear algebra. Just a quick overview. We're going to talk about the big idea, what I mean when I say IoT, because that's kind of important if we're going to talk about IoT security. And then we're going to break it down. We're going to look at the edge. We're going to look at everything else. And then we're going to talk specifically about data related to IoT, because that's kind of the most important part if we're being honest with ourselves, right? So a quick introduction, Joel did a great job introducing me. That's pretty much it. I don't know about the remarkable thing, but I have had some industry experience. I came to Purdue in 2005. I actually started as a physics student here. I discovered in my physics classes that my favorite thing was actually the labs and building all of our models in VPython. So I thought maybe it was wise to switch to computer science. So I switched to computer science and never looked back. I've been loving it ever since. So I graduated in 2009 then, and during my time here, I ended up finding some really cool research project with CERIAS analyzing malware. We got funded from MITRE, ended up doing a bunch of honey client research, which was basically going out, browsing the web, looking for malware, actively looking for malware, client-side attacks, things like that. We'd be able to snapshot images, sandbox it off, run it, analyze it, all of that sort of thing. So it was a cool research project. It led me to get an internship with NASA, which was awesome. I went down to Johnson Space Center, worked in mission control for a summer, which was pretty exciting, doing malware and software analysis projects for them. But then in 2008, before I even graduated, the world kind of threw a wrench in my plans to work for NASA forever. And that wrench was that we were no longer going to go into space, right? So we had a presidential election, things changed. 2008, we're no longer going to care about the shuttle program. After 3 years, it's retired. So my shuttle project, my software analysis related to that was basically useless. So I pivoted my career and ended up in intelligence. I worked out at NSA for the remainder of that, about 6 years before moving back to Indy last summer. With my wife. We live in the Indianapolis area now. I work downtown at Pondurance, and I've been loving that. It's definitely a change from government. So, it's a different pace. It's a different thing altogether. So it's been a lot of fun. So hopefully that's enough about me. I know you didn't come here to hear my life story or anything. If you did, just check out my Facebook page. It's all on there. Not because I put it on there, but because my wife did. But yeah, so let's talk about the big idea of IoT. What is IoT? What do I mean? What am I talking about? Because saying IoT is kind of like saying cyber, right? What does that even mean? So this slide is everything that I know right now about IoT. And this slide is everything I know about IoT security. I don't do animations in my slides, so there is no bullet points or anything that didn't show up. They're blank. But that's it. Anybody have any questions? But really, okay, so everything I think I know, right? Because we still have yet to truly define what we mean when we say IoT. So I did my best to try and break it down into components that sort of make sense. Has anybody seen these terms used before? this IoT ecosystem. Anybody, just to show of hands, I'm out of curiosity, who's heard the term the edge before? Just a couple, a few, maybe, kind of. How about the fog or the mist? Yeah, okay, the cloud. Everyone should have heard of the cloud, right? So these are kind of the components of what makes up this IoT ecosystem to the best that I can figure it out. And we'll break down what, each one of those things means here in a second, so that as we go forward and we're talking about them, it makes a little bit more sense. So throw the ecosystem to the back burner just for a minute. And let's think about what is actually the big idea? Because we'll talk all day about the frameworks and the architectures and all of that. But why is IoT a thing, right? Is it because a smart toaster really enhances our life that much? Not really. I mean, you still have to go and put the bread in and get the toast out, right? So the fact that it alerts you when it's done is really not very helpful. You know it's going to be done in roughly 45 seconds, right? You're making toast. It's not that hard. So why are these things even around? Well, I can test that it's basically these 4 bullet points here. Data, 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 and then that last thing, which is going to play a little bit of a role when we talk about security, is that it's simple. Simple to set up, simple to use. We have this whole concept of, a maker. Has anybody heard that terminology? Being boiler makers. I know they've done a lot of play on words with that lately, but in the last few years that terminology has really kind of risen up to mean somebody who, builds things at home, typically with Raspberry Pis or Arduinos, some sort of electronics like that, right? And that simple concept of IoT is what's really allowed that. It's cheaper, it's easier. You no longer have to go, and when I was 10 years old trying to build something, I had to go and buy breadboards and every single individual component from Radio Shack, and an LED, a little LED costs like $4, and I'm 10 years old. That's 2 weeks worth of chores to buy an LED. Right now you can, and for $4 you can buy 1,000 LEDs. So that simple piece is going to be an important part of what we talk about. But the rest of everything about IoT is all about the data. Here's a couple of headlines that we'll probably come back to when we dive into this a little bit more, that just kind of show that surface level. Everybody knows these ideas of collecting data and targeting ads, right? When General Motors was asked why they care what you listen to in your car, what's the answer that they give you? We want to give you better ads based on your listening habits, right? At the halfway point, maybe a little further down in this talk, I'm going to tell you why I think that that's probably BS. But we'll get there. Alphabet, Smart City, everybody knows that Alphabet is Google's parent company. They have plans to build this huge smart city on the waterfront of Lake Ontario in downtown Toronto. It's going to be awesome. Everybody's, going to live there and be happy. But of course, you look at the headlines, and we're already thinking about the whole issue of privacy, right? Sparking concerns over the data use. You're going to collect all this data about people's living habits, and what are you going to do with it? We'll get to that. All right, so considering the ecosystem, considering the data, the simplicity, those kind of overarching topics as the meaning of IoT, let's dive in and let's talk about a little bit about each one of those kind of components. So going back to the ecosystem, the edge. What is the edge? Someone throw out an example for me. What is the edge? What does that mean? Anybody? Yeah, devices. Perfect. Any examples?
Like a sensor in the field, like if you've got infrastructure that you manage as part of like an electrical company, you've got different sensors all around your infrastructure that let you monitor devices and input and output, and so that would be the edge of your network as an electrical company.
Yeah, that's great. That's a great example for an electrical company or utilities company. We're seeing the edge pop up everywhere, right? We're seeing the edge pop up in people's homes. We've got smart devices like Amazon Echo and Philips Hue bulbs. I mean, who would have thought 20 years ago that a light bulb could be part of the edge, right? That's kind of crazy, but now it's a reality. That's exactly what the edge is. It's all of those peripheral sensors. And the thing about the edge is that you cannot physically secure it, right? You cannot physically secure the hardware any longer. In the days of server rooms, that was pretty easy. You lock a door, you have access, PIN codes, whatever, badges to get in and out. You can control that access pretty tightly. You can literally secure the hardware. Well, in IoT, with the edge, you cannot do that. It's literally impossible. So, what does that lead to, of course? You've got a lot of hardware-related vulnerabilities. You have a lot of hardware-related, security issues you have to be concerned of. Just at a show of hands, you see this picture up here. Who's seen this thing before, a JTAGulator? A couple? Who knows does anybody in here know what JTAG or UART, does anyone know what those are? So just a quick TLDR if you don't. Those are basically serial debug ports. You can solder onto them, you can wire into them. Sometimes devices in the field, like an IP camera that's pretty cheap, is even nice enough to have headers on these ports for you. You don't even have to solder, you just plug in jumper cables, right? Well, the JTAGulator is a device that you can buy for $170 that allows you to solder on and send serial commands over those ports. Basically, there's a little bit more to it, but that's basically it. So, of course, when you sign into something or when you connect to some port like that and it's totally unauthenticated and you just start sending serial commands, what do you expect to happen? Well, you can start to do some pretty interesting things. A couple years ago, I was part of a team out in Maryland in a collaboration with Booz Allen Hamilton where we were able to solder on to a JTAG header that was on the Amazon Echo version 1. They actually had it protected. Amazon does a pretty good job of that. But there was a 0-day, so you're able to throw the exploit and gain root access through this serial port and start sending whatever serial commands you wanted. So you could basically control the whole device. You had physical access, but you could basically do things like turn the mic on always. Turn off the blue ring that indicated that it was listening, right? You could do anything like that. You can see right away why that would be kind of scary. That vulnerability was disclosed and patched by Amazon. So if you have anything that's been connected recently or updated recently regarding the Echo, that has been patched. But the physical vulnerabilities are definitely a real thing we have to be concerned with now. Whereas in the past, those were kind of more along the lines of an insider threat or infiltration or something. Now they're just everywhere, right? Cannot secure these things physically. So debug ports, anything like that, basically any sort of input-output that you can connect to becomes a new threat surface. Along those same lines, of course, the interface between software and hardware is firmware. Firmware has tons of vulnerabilities in IoT devices. Has anybody played with any IoT firmware? I see a few nodding heads. Yeah. So this is really fun, right? So there's conventional vulnerabilities in firmware, and those really honestly are the hardest and most boring ones. You can find things like, essentially programming errors like buffer overflow, heap overflow, those sorts of things. You have all those conventional vulnerabilities. But in addition to that, you have a bunch of really interesting things, like you may find stored keys, right? Like the encryption key is just in the firmware binary. So if you just strings it, there it is. Well, encryption no longer matters, right? If you have the key, you have things like, firmware will load keys into memory. So you can just dump memory. Remember that hardware access. If you can get on, I actually have several of these, but if you can get access to the chip, then you can just dump the memory at any time. There's several little clips and different things you can buy depending on what type of memory chip is on the board. You can just connect up and dump the memory. So you could do that. What about updates? You think updating firmware, is that an authenticated process or anything like that? Yeah, right. I wish, right? So many of these updates, firmware updates, no authentication, no verification, totally unsigned, just whatever. You send some of these devices the correct network packets and they'll say, oh, hey, I have a new firmware, and just update whatever you send it, right? Now, of course, Amazon and some of the, Google and some of those major players, it's not that bad. But when you buy that cheap $8 IP camera that gets shipped over here from China, you could probably expect things like that. So that kind of brings me to this then, because we just talked about unsigned firmware, updates, authentication. What's the major problem with authentication in IoT devices specifically? It's right up there on the slide. Well, the authentication piece would be encrypted.
If it's HTTP.
Well, HTTPS, let's say. Say we did a little better and we did HTTPS. But what is that? What's like that top bullet point? Yeah, there's so many things to authenticate. And when do you need to authenticate them? Every time they transmit data? Do you establish a session and let it transmit over a session, like you would with a user, right, in a browser or something? Can you trust that when you know that that device is not a user? So many things that traditional authentication methods that are based mostly in HTTP become really challenging. And I'll show you why, I think, on this slide, because we've already heard some suggestions for how to fix that, right? Like, oh, we could go with elliptic curve crypto. What does that do? Reduces the key size that's necessary for a particular level of security. So smaller key means less compute necessary. So we can use that and compute faster. Okay, we've heard blockchain. Who's heard of blockchain, right? Do you guys have a class on blockchain? Is that like CS 304 or something now? I wouldn't be surprised, right? But this graph kind of tells you an interesting picture. So Bitcoin, you know very well that Bitcoin uses blockchain as its methodology to determine whether or not a particular transaction is valid, which is essentially what you're doing with authentication, right? You're determining who is who and make sure that that transaction between the two parties is valid. So Bitcoin uses blockchain, which is based on proof of work. Am I speaking Greek, or has everybody got this? Yeah. And proof of work, we know, doesn't scale, right? It doesn't scale to this tune. Transactions per second, Bitcoin doesn't even register on this graph, right? There's something like a few 100,000 Bitcoin transactions ever in the history of Bitcoin, and they're already having scaling problems. Because, and I actually have, if anybody wants to see this, I have a site where it'll show you how blockchain works, but I can skip that if I'm assuming this audience pretty much knows how that works. But basically what it does is, you build one component in the chain, and then it has, a hash, and then the next component references the previous hash, and the next component references the previous hash. So at any point, if you change any one of those, then everything after that has to be re-verified. In order to re-verify those hashes, every single node in the entire blockchain network has to redo this very complex compute problem, right? That's what proof of work is. Every single node has to now go back and verify every single one of those transactions. So any sort of change, incredibly expensive. Who sees a problem with that with IoT?
IoT's limited in memory and stuff.
Yeah, but this is not even talking about the physical capabilities of IoT. Like, let's say we're just verifying it on the back end. We're not even trying to do this on the sensors or the devices or the edge itself. Let's say we have a way of doing it on the back end. How often do you need to change historical IoT whatever? Maybe, or maybe even more, right? So this is, untenable. And as proof of that, you're looking at Bitcoin and Ether, Ether's already switching to a different algorithm altogether called proof of stake, if you guys are familiar with that. But you look at this graph, and transactions per second for something like Visa, which is, of course, what Bitcoin aspires to be, right? Bitcoin aspires to be the next Visa. You're looking at like 1,800 transactions per second. And Bitcoin has, 18, and they're already having trouble scaling that. So blockchain is not the answer for IoT security. There's some other things related to that people have been trying to work out, like transaction chains, if anyone's heard of that. Basically reduces the number of nodes that have to confirm whether or not a particular transaction is valid. But even those aren't scaling to the level. With IoT data, we're not talking about thousands of transactions per second anymore. We're talking about potentially millions or billions. So there has to be another way. In talking about the edge and talking about all of this stuff, I would be remiss if I didn't at least bring up the payloads that were most popular last year. So has anybody heard of an extremely popular IoT payload that's delivered to the edge? What's it called? Mirai. And if you can read this graph, Like over half of these are some variant of Mirai. And what did Mirai do? Was it cool? Was it tech savvy? No, it logged in. That's it. Telnet, right? Telnet was running on these things by default with default creds. Mirai logged in. And then there was some variant of it that came along, and if the default creds didn't work, then it tried some very common creds and logged in. There was really no exploit necessary. There was even really not a particular software vulnerability. It was just utilizing the things that were running on these devices. So that kind of gets me to this next section, if you will. Talking a little bit about the edge, we know there's the physical stuff. We talked about the payloads. We talked about some of the encryption, the authentication challenges for so many things on the edge. You know, let's talk about the more interesting piece. The mist, the fog, the whatever it's called, I don't know. Let's define it a little better, probably a good idea. I found this graph. I put it up here because I really don't know what it means. You know, there's like, if you Google this, there's 1,000 different graphs and they all have something different in there. The mist to me sounds a lot like the cloud. It sounds a lot like compute cloud, right? If you think about EC2 or Elasticsearch or something like that, that's what is like mist. So I don't even use that term really. But the fog to me has a pretty definitive, you know, way of thinking about it. The fog is when you can extend cloud capabilities closer to the edge. So who has smart devices at home? Anybody? Do you have with those devices, do you have a hub? Like your Philips Hue bulbs, do they connect directly to the internet? What do they connect to? They connect to a hub, right? You need some sort of Philips Hue hub, and that hub plugs into your router, and then that's how it communicates out from there. Without that hub, the Hue bulbs don't work. They have some sort of proprietary communication between them, or maybe some other shortwave communication between them. Has anybody seen that before, that kind of model? So that hub device, that fits perfectly into the fog, because that's a thing that is kind of controlled by Philips or kind of controlled by the vendor of whatever solution you're using, right? It's updated by them. You rely on them for security of that. All you do essentially is plug it in. In addition to that, it has much better capabilities than the bulb itself. The light bulb connects to this thing, and this thing is actually powerful enough to run little web servers, give you an interface, you know, to talk to your light bulbs, all of that sort of stuff. There's actually a decent amount of processing power on there. So you extend some of that typical cloud capability closer to the edge. Hub is a great example. That's what I would call the fog, if you see that term anywhere. So we're going to talk a little bit about that. So, what are the components of that fog, cloud, etc.? This is going to blow your mind because I'm sure you guys have never seen these components before. There's obviously going to be networking components, messaging components, total ecosystems that are entirely separate from both of those things. And then, of course, the data is the primary component. Where have we seen those same four components before? Who can think of that? What other sort of like entity or thing with regard to technology would have those four same things? Cell phones, yeah, that would be a good answer. Like, I guess if you think about a 3G, 4G, LTE, etc., yeah. But even before that, what else?
Just normal computer.
Yes, exactly. The entire model is based off of what we already understand, right? When we started making home PCs. So when Windows became a thing and everybody wanted to get a computer at their home, it was essentially the same idea. I don't know, a Windows 95 machine is really probably less powerful than some of the edge devices we have now. You look at a Raspberry Pi 3, it's more power, more compute power than my very first Windows 95 PC. So really, this is just kind of a repeat of that, you know, same exact model, with, of course, improvements along the way. The sad thing is, and of course the joke is, that, you know, we haven't really learned from our mistakes. With IoT, I always say, it's like, remember how 1995 was, which I'm sure you guys, for the most part, don't, unless there's some grad students in here. Are you guys all grad students, undergrad? Is it a mix of the two? A mix? Okay. So the grad students might remember what it was like in 1995 for attackers. It was a heyday, right? You could just pretty much own whatever Windows box you wanted. That's where we are now with IoT. We didn't learn hardly anything, it seemed like. I had high hopes because we did with mobile, right? When we started developing Android and iOS came out, and we had a much more secure mobile platform from the start than we did, PC-based operating systems. But we've reverted to that old model with IoT. And there's a lot of reasons why for that. Let's start breaking down a few of those components because this is interesting to me. You talk about securing IoT networking. Whenever somebody says that to me, hey, we secure IoT networks, I always ask, well, which part? And they're like, well, all of it. So I break that down a little more, and I'm like, what do you mean? I'm curious because you've got, with IoT, you have, a user connecting to a standalone device. You have a user connecting to a cloud device or a cloud-connected device. You have a user connecting to the hub. You have a device connecting to a hub. You have the hub to the cloud, the user to the cloud, the device to the device, the device to the cloud. And most of the time I just get blank stares back at me when I list out some of those things. They're like, what? So the networking component of this is suddenly wildly complex, right? Whereas before, in that 1995 Windows operating system model, we kind of had, home PC, modem, internet. Well, that's gone. Now this is what we have to deal with. This tangled web of mesh networks that connect to everything else, and who knows, your light bulb connects to a hub, which connects to your router sometimes, but other times it actually connects to a device that's hanging on a radio or a telephone pole in your neighborhood, and that device connects to LTE, and that device, that connects up to the cloud that way. Who's seen that model? Anybody have a home security system? Yeah, well, they have home security systems that will connect to like a neighborhood hub in a mesh networking system, and then the neighborhood hub connects via LTE. It's all very interesting, and it leads to this huge tangled mess of very cool networking vulnerabilities. Well, I say cool, but so you can attack any one of these vectors depending on what your implementation is and what that IoT looks like in this particular scenario. I remember when they came at my townhouse in Maryland, they came and installed a smart meter. And I was asking BGE, which is the electric company out there, I was asking the tech how exactly this thing worked. And he said, oh no, it's very secure. You don't connect it to your home network or anything like that, so it can't get any malware. I'm like, well, how do you connect to it? He's like, well, it connects to that thing over there on this telephone pole, which is basically a mesh network amplifier. And that amplifier had, LTE capabilities. So I was like, all right, well, how do you connect to it right now? I see you're plugged in. He's like, oh no, there's no way to connect to it physically. And I was like, but you're literally plugged in now. And he's like, oh, well, that's just for me. I'm the only one that can do that. So, once he left, I popped open the box and I looked at the pins. There's like a couple of generic pins, right? So I went and I found a cord that kind of matched that, broke it out, and lo and behold, what did I find? Of course, it's a serial connection, right? Just about anybody could just buy a device and plug it in there. So there's the physical aspect coming back to you. But then there's also the networking aspect that concerns me. You have this thing on a telephone pole that can connect to LTE, and it has basically, nobody knows how it works. BGE bought it from somebody else and put it up there for the smart meters, right? And that somebody else is responsible for securing it. So what's to say I don't just climb up there and run a wire down? I don't know. So on the lines of networking and all of these different attack surfaces, who's heard of DNS rebinding? A couple? I feel like everyone's being shy. The same two guys have heard of everything. Anybody else heard of DNS rebinding? No? All right, well, we'll walk through it real quick. How about this? Who's heard of the same origin policy? That you should have heard of in your networking classes, right? A little bit of HTTP, something like that. Basically, what same origin policy says is any sort of client-side resource cannot request a resource from, a different origin. So you can't write a JavaScript that will run on the client side and request resources from some origin other than the one that served it, right? You've encountered this if you've done some sort of web development that you want to query external APIs. You want to build your own website that queries a Google API. If you don't set anything up, if you don't do anything, that initial query is going to fail and your browser is going to say, hey, same origin policy, man. That stuff is not on the same server that this JavaScript came from. So DNS rebinding is a way to get around that, as kind of indicated there by that picture. It's kind of funny. Same origin policy in this case is the gate in the middle of the road there. Some top quality security. So how does it work? Well, it's relatively simple. As an attacker, let's say I'm an attacker, I control a server and I control a DNS response. Could be a DNS server. You could just be, blasting out responses in hopes that they've, queried for your site, whatever, depending on your method of giving them the JavaScript to begin with. But the easiest way is to host the DNS server, host the website where you have some bad JS. It gets requested. In order to get that, there's a DNS request that's issued. You send them back a legitimate response. They go and they get bad JS. And inside of bad JS, what you have now is you have requests to your website, whatever that is. Let's just call it bad.com. You have a whole bunch of requests that go to bad.com/temperature. And you'll see why in a minute. And what you do in your initial DNS response that serves the JavaScript, you set a timeout policy or a cache policy really, really low so that that DNS cache flows out really quickly. So then when that expires, their browser will reissue another DNS request because the JavaScript is sitting there requesting bad.com/temperature over and over again, right? So then they do that. And now you see the request come in a second time, and instead the response is 192.168.1.5. Why would you send that response?
They expect you to be on a local network.
Exactly. Now suddenly you're sending, that JavaScript is sending this request to 192.168.1.5/temperature. And if that's your thermostat and that's a valid API query for your thermostat, guess what? Game over. That's DNS rebinding. I actually have a demonstration of it if you guys would like to see. There's tons of DNS rebinding CVEs, which we'll get to here in a second. Let me see if I can pull up this demo real quick, because it's kind of cool. Oh yeah, I should also mention you don't have to write any of this code yourself. You can go and download toolkits, whatever. I have a link to a project in GitHub that lets you do this right here if you really want to. So I think this is it, if I remember correctly. Yeah, so here's a demo that does it. And it says, you've chosen not to run the proof of concept, but you can change your mind. I'm going to turn on the network inspection here so you can see what's happening. You can say I changed my mind, and now you can see all of those requests constantly going over and over and over and over again. And this isn't actually doing anything malicious. It's just showing you those requests and how they can resolve to internal IPs if you don't block that, which most home networks don't block that. There's a simple answer. You can block, of course, any DNS response that has an internal IP in the response, but who does that at home? Anybody? Even here, even at CERIAS, at a security seminar, nobody does that. So how would you expect the average home user with a Google Home or a Roku or a thermostat or Philips Hue bridge to do that, right? It's not likely to happen. And of course, none of these things are probably going to be found on this network, but it's searching. I'll go ahead and stop it. All right, no more DNS rebinding attacks.
You will want to get ICAP on you.
Yeah, I was just testing something. So it's kind of cool when you think about it, and it's pretty easy to pull off, right? You don't even have to really do anything as an attacker. You just go download the code, host a website, whatever. There is one cool caveat to that improves the probability of that succeeding, and that is when you initially download that bad JS, it can actually just scan the internal network, right? You can just use JavaScript to try and see which hosts are online. So then when you go and do your rebinding attack, you only have to check the IPs that are actually there. You don't have to check the entire internal network. But hey, you know, 192.168 Class C, that's only 254 IPs, so that's going to go by pretty quick. If you're smart and use a 10 dot, it'll take them a lot longer to brute force your entire internal network. So CVEs, yeah, lots, all over the place, vulnerabilities everywhere, right? Even quality devices have this particular vulnerability just because it's not on the device to implement this security, right? It's on the user to implement this at their, you know, in their DNS policy, in your router, basically. You have to set up your firewall, basically, to reject these. So just some numbers of switches, routers, etc. 87% of them are vulnerable to this. You've got your Google, Roku, Apple stuff, 78%. You know, here's an interesting one here. 66% of printers. That's 165 million printers, 160 million IP cameras. It's 75% of IP cameras vulnerable to this. So yeah, this is a real thing. So how do we fix this secure networking thing with IoT? If there's all these components and there's all these like very basic vulnerabilities. DNS Rebinding is not a new thing, by the way. That was like really cool when DNS first started. So again, we're like back to the beginning. You know, how do you fix this? Well, there's some people trying to work on this, honestly. But it's hard for IoT because right now our secure networking is totally reliant on HTTPS, right? That's pretty much how the internet communicates for our usage. At the application layer, HTTPS is by far the most common protocol. So authentication relies on HTTPS. And what's interesting about that, of course, is to authenticate a person, what do we rely on most? In that realm, what do we rely on most? Passwords. Well, the FIDO Alliance, which is an alliance of really smart people, much smarter than me, working for big companies that are very important, you know, they kind of created this graph about passwords, where currently this is where we are. Passwords are poor usability and weak security. And where we want to try to get is easy usability and strong security. So there's a lot of people working on that. But why do you think passwords are poor usability? I would almost argue that is why they're weak security. Because you have to remember them, right? That's the biggest vulnerability to the password system, is the fact that people use easy ones so that you can remember them. Or they write them down on a Post-it note. Or they store them on a text file on their desktop, or whatever it may be, right? That's definitely one of the things. Because the encryption that's underlying here is, you know, cannot be broken. AES 256 is, you know, 70 million years worth of brute force with all the computing power in the world. So we're not breaking the encryption by brute force. There may be a side channel attack or something like that, but it's not going to happen via brute force. What's the usability issue with them? Time. Right? Wouldn't it be nice if authentication were so easy that as soon as you wanted to load a particular resource that you should have access to, it worked? Well, there's people working on that sort of thing. You know, biometrics is a step toward that, right? That's the whole point of it, is that you don't have to take the time to punch out this password on your phone. How would you put in a password on a Google Glass? I have no idea, right? Even on a phone, it can be hard if you have a long, complicated password. Some of the in-between steps have really helped. Anybody use a password manager? All right, that's good. I use 1Password. I love that. You just like copy, paste, copy, paste. Of course, every time I use 1Password and copy and paste, then I immediately go back to my notes and copy a useless string that I keep in my notes, because you don't want to leave your password copied on the clipboard, right? So there's still, again, like a usability thing there. It's pretty hard. It's pretty hard to secure networking with IoT thing. All right, enough about networking. Let's talk about something more interesting. Who's heard of RabbitMQ? No? Or NATS.io? No? Sweet. This will be a new slide for everybody then. Everybody know what a queue is? This is like Data Structures 101, freshman year, that class that you had at 7:30 in the morning. Well, for me, that's what it was anyways. That, and then it was followed by chemistry, which was absolutely brutal. So everybody knows what a queue is. We don't have to go through and talk about that. RabbitMQ is an implementation of a queue that's commonly used for IoT stuff. So it's pretty neat. You know, you can push stuff to the queue. You can pop stuff out. You can actually use RabbitMQ and use it as a stack also if you wanted. So you can do first in, first out. You can do last in, first out. Depends on how you set it up. Of course, by default, none of this, literally none of this is secure. And, even when you do secure it, it's still just kind of basic, right? TLS support. So here's the official RabbitMQ docs on TLS support. Remember that simple thing? Like why we do IoT is kind of because it's simple and fun. So let's say you set up RabbitMQ at home and you want to now secure some of your smart things that are pushing data in and out of these queues. This is all you have to do right here. You just come to this page, and follow these instructions. It's really no problem. I mean, I don't know what everybody's complaining about. Security is easy, right? Is it done yet? Oh, there we go. Finally got to the end, right? Just for TLS? That's it? That's all I'm doing with this whole page of instructions? That does not go by the whole IoT simple thing, right? So what happens instead of all of this stuff? Nothing, right? We leave it, whatever. It's just my toaster, it's just my fridge, it's just whatever. I don't have to worry about it. Exactly. Usability thing, right? Where'd my presentation go? There it is. So you've got this whole idea of simplicity with IoT, and with some of these things you have very complex setups just to achieve basic levels of security. Nats.io is a really, really cool input-output queue. It's kind of like Redis, but Redis that's like, everybody, do you guys know what Redis is? Do you use Redis? So it's kind of like Redis, except trim like 95% of the capability and stick with just the part that's awesome. Right? And that's what Nats.io is. And a lot of companies are actually going to it because it's very, very slim and it's bare bones to just process as many messages in and out as possible, right? Really cool. Check it out. They do offer authentication. They offer TLS. I could show you the TLS docs. They look a lot like the RabbitMQ docs. And here's your authentication. It's in a config. Hey, that's great. You can config a username and password. But hold on, there's more. The password, we're going to go ahead and keep that stored in the config as a hash. So it's not in plain text. We're going to use Bcrypt, and now it's safe, right? Because nobody has ever passed the hash before. That's definitely not a thing, right?
I'm just waiting to hear, oh, by the way, it's an MD5 hash.
It's not MD5. It's better than that. I think it's, what is it, with SHA-256, I think, with Bcrypt. So it's a solid hash. You're not going to have many collisions, but, it's still a hash of a password in a config file, which is interesting. MQTT, who's heard of this queuing system? Sweet. Wow, I got to get you guys into like some IoT clubs or something. Is there like a maker club here? No? Oh, gonna have to start one. So MQTT is another queuing system that's really, really, really popular in IoT. And the reason is because MQTT is also the protocol. This doesn't use HTTP. MQTT is the protocol, right? Also. So
Is it over TCP or UDP?
I think it's over TCP. And I think that, well, I have to check that actually. That's a good question. But I think it is because the way that it works is you essentially have this concept of a broker, which is a server. You run a server side, and that's a broker. And you can publish messages to the broker, and then you can consume messages off the other side of the broker, right? And those messages all belong to what's called a topic. So you define a topic, you can publish to that topic, and consumers of that, subscribers basically, can pull all of those messages in real time. It's pretty cool. So, thinking about this. Shodan, you can see the results there. 57,458 last time I did this query. MQTT servers that I found in a simple Shodan search for MQTT. Notice the search there. It's not some like hard query where you have to know a bunch of information about a protocol. You can literally ask Shodan to find me MQTT, and that's what it does, right? So, is there anything interesting on any of these brokers? What do you guys think? So I wrote a little script. I wrote this subscript here, this MQTT subscript. Let me actually, I'll pull that up and open that in my text editor here. Let's throw that open. Pretty simple. Import a library. This is just Python. You import a library, and then you connect, give it the URL of the broker, couple of config options, go, right? Listen for messages. So one of the cool things is with MQTT is that you can use a pound symbol or a hashtag, depending on how young you are. You can use a hashtag like this, and that will subscribe me to all messages. So what I'm asking it to do right now is subscribe me to all messages on the public broker. So let's just do that. And there they are. So I'm receiving all messages, and it's printing out the topic followed by the data that's in that topic. So one day when I was looking through, just kind of parsing, I wrote a little parser for this, which I won't go into, but I wrote a little parser just to see if there's like anything interesting here. Let me kill this before it kills my Mac. And what I found, I'm hoping it's still there, is I found something interesting that was like, seemed real. T-mill. A topic called T-mill. Anybody heard of T-mill? There it is. T-mill, this seemed like real, and it was like T-mill / factory / lights, T-mill / factory / pickling or picking, packaging, environment, like all of these things. I was like, wow, this kind of seems real. There's some temperature, humidity readings, right? I was like, maybe this is just a test. I don't know. But then at one point, I actually saw a whole bunch of shipping information come across. It's like people's addresses and handwritten thank you notes, like thank you for buying this shirt, right? And so I was like, well, what in the world is T-mill? I never heard of that. So of course I came to trusty Google, and I Googled that, and I discovered that T-mill is actually a legitimate business. I don't know how long it'll take to load here, but maybe it's blocked or something, I don't know. So what T-mill is it's a website that will allow you to set up a store online to sell your own t-shirts. And for some reason, they're using a public MQTT broker to record all of those orders. And I thought, no way, like no way that's real, right? This is totally a test server or something. Hey, there it goes. Pretty reliable website too. I was like, this has to be test data. So I had a friend order a shirt, and I was parsing the data, and there it was.
Oh my God.
It's like, at best, what I'm seriously hoping is that they're just like duplicating some production data to a test environment so that they have real data. But I don't know. I mean, it seemed like it was pretty real data to me. And you just saw me run a script that, like basically accesses it all. Very, very simple script. This is it. Just a library and a couple of function calls. Question?
Have you told them that this exists, or that they're sending all their data out into the internet?
So that's like a great question, right? So I did submit something to their page because I couldn't find any information on like who ran this thing. So I just submitted it under like a contact us thing. It's been, I don't know, like 6 weeks. I haven't heard anything. So I have no idea how to like get in touch with them. It's not a US-based company.
Oh, okay. I can see it's a Great Britain company in their TPS symbol.
So yeah, that's MQTT for you. No security, public brokers, whatever. Pretty cool, pretty scary. If you're running a business off of that, particularly scary, right? Oh, so we can read the messages, so what, right? We saw some information about their factory floor. We would see any orders that came in. You'd see all of that. So what?
Social engineering time.
But, that's too hard. What is MQTT? What were we doing just now? That, right? What about the other side? What if I just like started publishing things to their topic? Could I do that? I tested it with one thing that seemed very innocuous. It was like a temperature reading, right? And it worked. So I hope they're not making decisions based on whatever they're subscribing to from these feeds, right? Luckily, those readings come in like every second. So like the very next one was not mine. But imagine if I just started posting a whole bunch of like address information. Just publish all of this order information. Publish these shipping addresses, right? I don't know, maybe I could publish everyone's shipping address and get you all free t-shirts. I have no idea how they're making decisions on the back end, but the fact that you could just not only subscribe and read, but you could just publish whatever data you want there is pretty scary. Imagine if they were like using this to monitor their factory floor and I just ran a script that started publishing that the temperature was 400 degrees Celsius. Would there be people, running to the factory to see if it was on fire? I don't know. I hope not. So how do you secure something like that, right? How do you secure MQTT, something that doesn't use HTTP at all? Well, most of the solutions right now are enterprise solutions. It's pretty tough to do on your own, but you can do it. You can do it with something called a third-party broker, which is basically, you can build a third-party broker yourself. Most people don't. But basically, it's a server that runs a broker but also connects to Auth0 using HTTP, or HTTPS. So we're still defaulting back to the HTTP-based authentication, but we're interlacing that with the MQTT broker on one server, essentially. Of course, that's expensive. It's harder. It's tough to do at home. It goes against this simple model, right? Question?
Can't you just isolate it so it actually can't talk out, and then you don't have to worry about like all that complicated authentication?
Well, you could try that, right? But then again, it has to talk to something. It has to talk to whatever's publishing and whatever's subscribing. So if you have that internal network there, right, you just saw that DNS rebinding stuff. I mean, you could pretty easily just start publishing data from a JavaScript too, right? So isolation, segmenting the network like that alone is not enough because that's kind of like security by obscurity, right? We're just going to hide it from the internet and that makes us good. Actually, I do a whole nother talk on air gapping, which is fun because you get a whole bunch of industry partners in a room and they're all like, oh, we don't have to worry about any of this. All of our stuff's air gapped. It's like you just got an email alert from a stamping machine that's on your assembly line, didn't you? Yep. It's like, well, where did that email come from? I thought that thing was air-gapped. Most of the time, things aren't actually air-gapped. There's all kinds of other problems that go in with that, too. Who's heard of NodeRed? This is kind of a cool thing. So NodeRed is like this entire ecosystem. It's all based in Node.js. It's really cool. It's really sweet. And it allows you to do this visual type of programming where you can build, basically build a flow. So here I built a flow for basic like temperature API. Basically, this is like an API flow, right? So you can get a temperature or you can post a temperature and humidity actually. And that's basically what this describes. So you can post a temperature, you get a post reply that says it was successful, you store it in a Redis queue. Down here, I'm just debugging and subscribing to those queues to make sure the data is coming properly. Pretty cool thing. Pretty easy way to set up an API or connect in. You have all kinds of inputs. MQTT is an input and an output. So if you just stand up a server somewhere and you connect to that broker, you can visually program the rest of the flow, right? Using something like NodeRed. It's really, really cool. I use it at home a lot. For almost all of my projects, actually, I use this. What about security in NodeRed? Do you think it has any security by default? No, that would be silly. So, given that knowledge, is there anything live on the internet right now? Not much. I only found 362 NodeRed servers online. Luckily, NodeRed does have a relatively simple way to implement a basic username and password authentication to get access to the server. But we all know how easy that is to get past. And what's cool is NodeRed has given us an API, right? So you can do all of these things visually, or you can build any of this stuff directly through the API. So what have people done? Well, they've done some DNS rebinding. They found NodeRed running internally places that's not secure, And then they've decided, well, you know, if you look at this here, I'm going to deploy my own flow, but my flow is going to mine for Bitcoin. Why not? Now you've got this super powerful server that's running all of your NodeRed flows, and it's also running this hidden flow that's mining Bitcoin or Ether or whatever. Take your pick, Litecoin, you know, any number of them. Actually, that was a big enough problem, even though NodeRed is relatively new and relatively unknown, that they issued this tweet literally like a day before I first gave this talk, which I thought was hilarious. Whereas, like, you know, there have been some cases of unsecured NodeRed having crypto mining deployed. All you got to do is scan for port 1880 in order to find NodeRed on an environment. That's pretty easy. So don't expose NodeRed to the internet without proper security. Or, you know, don't expose NodeRed at all without proper security, because DNS Rebinding tells you I could do all this through JavaScript too, right? Pretty neat. Pretty scary. What about web interfaces? Who's seen that comic? Yeah, everybody? Little Bobby Tables? Everybody knows Little Bobby Tables. So one of the things that's interesting, all of these IoT devices, anything that you buy, anything that you have at your house, in a lot of the commercial solutions as well, they have web interfaces, right? Where you can log in and see the data and manipulate and set it up and configure and administrator and all that stuff, right? But what baffles me is that almost all of these things, IP cameras, doorbells, security systems, baby monitors, whatever, they have custom server, like custom HTTP servers for these things. It's like, why are you not using Nginx? Like, why'd you feel the need to write a custom HTTP server for your smart doorbell? That makes no sense to me. And of course, that's littered with all of the traditional vulnerabilities. You know, you've got a whole bunch of those that literally just inject input directly into queries, which we all know leads to little Bobby tables. And it's hilarious. It's just like even really popular routers like MikroTiks, where you craft the right query in the, you know, login to the MikroTik, and poof, you have admin access. It's amazing to me that all these things are just using, you know, custom home-rolled HTTP servers and web interfaces to do this. How about databases? MongoDB, who's used that? Yep, big old check mark, right? Pretty good security if you set it up right. It takes some time, but if you set it up right, pretty good security. How about Postgres? Same story, except with one caveat. Has anybody looked at the HBA conf file before? If you have, then you see this bottom line here, you know that's the default. What does that say?
Trust all.
Trust all, but from where? From the host. So if you're on the local host, you don't need to authenticate to log into the database. That's the one thing that most people miss with Postgres. If you're running Postgres, change that line, please. Even if you're on the local host, you should still have to log in with valid DB creds in order to gain access to the databases. But otherwise, pretty good security. These things are kind of peripheral to IoT at this point, right? They're all used in IoT, but not directly related. How about indices? Throwing your IoT data up in Elasticsearch. Is that pretty secure? I think we're pretty good there. Cloud is getting to a point where it's pretty good. Most of these cloud breaches are not some crazy cool exploit. They're like much simpler. I think an employee got phished and gave up creds or something like that, right? So, I know I'm running out of time here. If anybody has to go, feel free. I think it's just an hour, right? So, let's talk about the data real quick though. When I talk about securing data, I mean privacy. Everybody's talking about privacy. What does that mean? How can we get there? Do we even have it anymore in the day of the internet? I'm also kind of talking about perimeter security, just a little bit, and I'll explain why. So with regard to privacy, IP cameras, these are a thing. Who's got IP camera at their house? Could be a baby monitor, could be a security system. Any camera that connects to the internet essentially is an IP camera, right? We've already seen those have major vulnerabilities. So what? That's what I get from most people I talk to. So what? What can you do? You're going to watch my video? You're going to watch me eat dinner? All of that stuff, right? They don't really care about that. Well, they may say that they do, but they don't, because they keep buying all of these insecure devices, right? As long as the market doesn't demand something better, we're going to keep having these insecure devices. So my counter argument is, all right, well, what if I collected a whole bunch of data, a whole bunch of video data, performed some AI analysis on that and determined some sort of patterns about your life, and then I sold that? Would you be okay with that? And now all of a sudden the answer is no, right? Now all of a sudden it's an invasion of privacy. Well, going back to these headlines, how close are we getting to that? General Motors watches you listen to the radio. I told you at the beginning of this talk that when you ask General Motors why they're doing that, their answer is because we want to give you better ad content. And they've invested like billions of dollars into this sort of technology in a car, right? And I'm sitting there thinking, that just doesn't add up. So what? A tailored ad on the radio. Is that really going to make them billions of dollars? Like, are ad companies going to pay that much more money to have a tailored ad versus a generic ad? Probably. I just don't see it. So you think about it and you're like, well, what else could they do with that data? What else could they do by monitoring what you're listening to the radio? How could they sell that? Well, is anybody from Indy? So in Indy, there's a heavy metal station, X103, right? Anybody listen to that? X103? Yep. So I'm thinking more along the lines of General Motors watches you, listens to you, listen to X103. And then they correlate that with more aggressive driving behavior. And then they send that data to your insurance company or sell that data to your insurance company. And now, of course, your insurance company raises your rates because you're aggressive when you listen to this type of music. You could see that we could actually get to a model that's real time, right? As opposed to having a flat rate, like you pay $78 a month for car insurance, you could have a variable rate where you collect all this data about your habits, your driving habits, where you go, what you listen to, how it all correlates, and your rate fluctuates based on what you've done that month. Maybe they just have a surcharge, like an X103 surcharge, 4 cents per minute. When you listen to X103, you're going to be charged 4 cents a minute on your insurance bill, because that's the likelihood that something's going to happen goes up when you're doing that. When you start talking in those terms, now data becomes really fascinating, right? When you get away from the whole BS of like tailored ads, because that's what everybody's saying, but I don't believe it's true. There's going to be so much more than that. And imagine if we were collecting that fidelity of data, not just in the car, but across your entire life, AKA going back to the Alphabet Smart City headline. That would be pretty interesting, right? If you could collect that sort of fidelity about your entire life, the connections that you could make, the information that you could sell, everything in our life, kind of goes back to that bottom dollar, and it would all be variable based on those habits and those things that you do. Health insurance could be the same way. Medical devices, I don't know if I have a slide for that. I do, right? Smartwatches. What if Apple starts selling that data to your insurance company? And the gyroscope, or whatever it's called in a watch, determines that you do this motion a lot, right? But you put on your insurance form that you're a non-smoker. And your insurance company says, well, your iWatch says otherwise. Now what? Is that an invasion of privacy? Maybe you have an itchy chin. I don't know. Or maybe you're hiding the fact that you're smoking and they know about it anyways now. And you could see where this could go really, really deep with medical data, right? This could go down a rabbit hole that we certainly don't have time to get to tonight. But you could see just basic habits like that, how they can influence your life, and why now IoT is really, truly about the data. It's not about the devices. It's not about the novelty. It's about the data. So when we talk about IoT security, this whole talk leading up to this point, you could almost make an argument that we don't really care about it. Securing all those other things, the edge, the hardware, the networking, the queues, the databases, really what we're getting at is that we truly need to secure data. That's what it's all about. If a device can be hacked but the data can't be modified, I don't care. And that's kind of where security researchers are going, right? Because data is what generates revenue with regard to IoT. And it makes for a very, very interesting threat landscape. Another example, going back to the car. Imagine you're driving along at night, it's 3 a.m., you're tired, your car senses that. What could now happen with that data? Your car knows you're tired, you're kind of weaving in your lane. What could you do with that information? The car company could A, forward that information to Starbucks, have them order you a coffee, have it be ready by the time you get there. Cool. All right. Maybe you even get a discount, a safe driver discount for pulling over or something. Cool. Or they could B, sell that to your insurance company so they can raise your rates. Now you're an unsafe driver, right? What do we do with that data? How do we secure that data? That's going to be the whole story. This is just for fun. I don't even know what this is. It's a smart soccer ball. Has anybody seen this? A smart soccer ball. It tracks how you kick it. And Adidas actually says on their website, for this ball that they're trying to sell for like $150, we're still working on getting you more information about the smart ball. But, buy it now and we'll let you know in the future. Why? Why in the world would they sell this? Because they're making a bet that someday, somehow, they're going to be able to tie this data back to some sort of revenue source, right? It's all about the data. Nobody needs a smart soccer ball. I love soccer. I play every week. And I would hate to miss a game because I didn't charge my ball.
Only 2,000 kicks a week.
Yeah. Yeah, right. That'd be gone in one night. That's everything I got for you guys. Hopefully you enjoyed it. Thanks for coming out tonight, and I'll stick around for questions.